a concentration of ore and the reactivity series. So can you please switch on your video so
Ma'am,
that I can
yes,
see you?
I'll
Hmm?
just 2 seconds.
Okay. So tell me first this one, concentration of ore without seeing any notebook or anything.
Okay. Ma'am, ore, then concentration of ore, metal with high reactivity, metal with medium reactivity, and metal with low reactivity. In
Hmm.
metal with high reactivity, there is electrolysis of molten ore,
Okay.
then pure metal,
Hmm.
and then there is in metals of low reactivity, there is sulfide ore, um, roasting, and then metal.
Okay. Hmm.
Ma- Ma'am, then metal with medium reactivity is there are two. There is carbonate ore and there is sulfide ore. In carbonate ore, yeah, there is
Without seeing you are
calcination.
telling, right?
Ma'am?
Without seeing you are telling, na?
Yes, ma'am.
Okay, okay. Hmm. And the last one was what?
Um, um, metals with medium reactivity.
Hmm.
Um, this is it. There are two. There is carbonate ore and there is sulfide ore. Um, carbonate ore is calcination,
Okay.
and
Okay. So ठीक है ठीक है. Now tell me the reactivity series one without seeing.
um, potassium, sodium,
Hmm.
uh, calcium, magnesium, aluminium, um,
Okay.
aluminium,
And
zinc, iron, tin, lead, hydrogen,
hmm.
hydrogen, copper, um, silver, and gold.
Okay. Shazan. Okay. Switch on. हाँ ठीक है. Now you tell me this one, the concentration of ore.
Ma'am, can I revise once?
Revise.
No, I just want to see. I just want to revise it once.
You are 8 minutes late and still you need to
Ma'am,
revise.
I was reading namaz. That's why.
ठीक है. 2 minutes. Now in the next, what we will learn the enrichment of ores. Huh. So what is enrichment of ores? Enrichment of ores means the undesirable impurities like soil.
Ma'am,
In soil, huh,
ma'am, I have to tell both the tables today.
the
Both the tables.
concentration of ores.
Okay,
This
only
one.
one. It's only one word.
Hmm.
Okay.
Okay. So enrichment of ore means the undesirable impurity. Like in soil, there's lot of impurities, right? In the sand also. Sand is not a pure sand. It's a mixture of all of the impurities. So which is found in ore are called gangue or matrix. So what is matrix or gangue? The impurities like the sand or the soil which we can found in ores. ठीक है, impurities कहाँ मिल रही है? In the ores. So that are known as matrix. Now The removal of matrix from the ore is called the enrichment or concentration of ore. Now you understood what is the meaning of enrichment. Enrichment means when we will remove the impurities from the sand or from the soil, so that process is known as the enrichment or concentration of ore. Okay, Riya, ठीक है?
Yes, ma'am.
And undesirable impurities like sand, oil, which are known as matrix, and the removal process is known as the enrichment. Enrichment means means removing all the impurities, and we are making it rich. So that is known as the enrichment or concentration of.
So, ma'am,
Now,
it's
huh,
like purification.
it's like purification. Huh, you can also say purification. The process used for the removing the gang from an ore are based on the differences between the physical and the chemical properties of the gang and the ore. Now, what all process which are involved in removing the matrix means the dirt, impurities from the sand or from the oil is based on the difference between physical and chemical properties, because in chemistry we have like for each compound what we have some physical properties as well as chemical properties. Chemical property means we have to mix something and we'll get something else in the output. And the physical properties means we'll talk about the nature, about the melting or boiling point like that. So here also in this process, in the matrix process, when we are removing the impurities, so in the removing part is based on the difference between physical as well as the chemical properties. Okay? Now depending upon the nature of impurity comes in physical or in chemical realm. Nature. Nature comes in physical property or in the chemical property.
Ma'am, physical
Huh.
property.
Yes, it's a physical property because nature, melting point, solidity, all comes in physical properties. Different separation techniques for enrichment of ores are also employed. Different separation technique comes under chemical properties, right? So again, we'll go through with this paragraph. What is enrichment of ore? Enrichment of ore means the impurities which is there in the sand or the soil, which are called as matrix, and the removal of the process from the sand or the matrix is known as the enrichment or concentration of ore. And the process which is used for removing the, you can say, the impurities from the matrix or gang is based on the difference between two chemical as well as the physical property. So physical property will depend upon the nature of impurities and the chemical properties will depend upon the different separation techniques. Okay? Understood? Acha, now tell me, Ria, what is enrichment? What is the meaning of enrichment of ore? It's
Ma'am,
simple. Huh.
removing impurities from the ore like soil and sand.
Okay, good. Now, second is extraction of metals. Present at the bottom of the activity series of flow reactivity. So after hydrogen, the rest which is below hydrogen all are less reactive, right? So now we'll talk about that. And this is our medium reactivity. And the next one is
Then
high reactivity. Okay. What Shazam?
I have done
Okay. Tell them.
concentration of flows are divided into three:
Hmm.
metals of high reactivity, metals of medium reactivity, metals of low reactivity. In
Hmm.
metals of high reactivity, we have sulfide ores,
Huh.
which goes through the process of wait, uh,
What?
we have sulfide ores in metals of high reactivity that goes through the
Hmm.
process of electrolysis and that gives us pure metal. And for the medium one, there are we got two ores. One is sulfide ore, one is carbonated ore. Carbonated ore goes through the process of calcination, and the sulfide ore goes through the process of roasting, which gives oxide of metal. Then then a reduction of metal, then purification of metal. And in the last one, which we have metals of low reactivity, we have sulfide ores, which which are roast. Wait, no, yeah, first one was roasting, and after that I'm forgetting.
Oh
Ah, yes,
God.
no, I forgot. After roasting, we get metal, and that metal is then refined.
Hmm. So this is the one now.
Hmm.
High, medium, and low. And in the high, there's two more, and medium is divided into carbonate and sulfide, and further this. Okay. So yaad kar lena, it's very important. Now next, extraction of metals, the metals which are below hydrogen, which are less reactive. So first is these metals being less reactive can be obtained by reducing their oxides to metal by heating alone. Now we'll go through. First is HGS, which is a mercury. So mercury, like when it is heated in a what?
Can you explain the line once again? I
Which
want
one?
for the first
Which one?
this enrichment of ores.
Okay. So enrichment of okay, Ria will explain. Ria, can you explain?
Ma'am, enrichment of ore is basically removing impurities from the ore like
Hmm.
soil and sand. Um,
Hmm.
and it is done like um, it depends, like the enrichment depends on the nature of the impurities and the different separation techniques.
Okay. So, see, Shazan, enrichment of ore means the impurities which is there in the sand and the soil. Okay, which is found in ore. The impurities which is found in ore that are known as gangue, or you can call it as matrix as well. So, when we will remove the matrix from that ore, it means the impurities when we remove from the particular ore are known as the enrichment, or you can say the concentration of ore. Okay, sorry, and the process which is used for removing the matrix from the ore will depend upon the difference between chemical and physical properties, because in chemistry for each of any compound we used to talk about both the chemical and physical properties, right? Chemical means when we will mix two things we'll get one output, and physical means we'll talk about the nature or any melting or boiling point or shape or that something like that. So here in the enrichment of force, the physical property will depend upon the nature of impurities, and the chemical properties will depend upon the different separation techniques. Okay? Different separation techniques which is used for removing the impurities from the matrix.
Okay, ma'am, can you give 2 minutes just to read this one? Don't scroll.
हाँ, read it. ठीक है? Now, what is extraction of metal? So first we will look about this low reactivity series, which is below hydrogen. First is HGS. So this is your HGS, which is a mercury sulfide. So when it is heated in air, now if we will heat this HGS in air, so what will happen? It will first change into oxide, means mercury oxide, which will be HgO, and then it will reduced into mercury metals on the further heating. Now, first is your HGS. It is combining with your oxygen, means on heating when we will combine this. So after heating, what we are getting? We are getting HgO, which is a mercuric oxide. And if we will further, it will further heat, then what will happen? It will reduced into a mercuric metal, means only Hg will remain. Okay? Now, see here.
Okay, ma'am, how we are getting sulfur dioxide over there?
Where?
I'm in the first one exam.
Okay, this one. See, Hg1O and SO2, it's 3 and O2 now, means total 6 oxygen. Okay? So here 2 oxygen and here 4 oxygen. So 2 plus 4 is equals to 6. ठीक है? पहले क्या हुआ? 1 second.
Not really.
Okay. So now, so Hg first, Hg will combine with O. Okay, so 2O, total 6 are there, so 2 means 4. Now 4 will be there, which is combining with your sulfur, so it will be 2SO2. Okay. Now what will happen if we will further heat HgO, so it will convert it into a mercury, which is your Hg, and some amount of oxygen will also release. Same for the copper glands, which is Cu2S. When it will combine with the oxygen in the form, like when we'll heat it, so it will first convert it into oxide. ठीक है, and sulfur dioxide again Shazan SO2 वो हो जाएगा. And on further heating, what will happen? On further heating, what will happen?
Copper metal.
It will give a copper metal and some remaining your sulfur dioxide. So what you have to do here, you have to learn, not basically learn, only you have to learn about HGS and Cu2S, and you have to learn the process that firstly we have to do with the oxygen, and secondly what we have to do, simply we have to combine, um, means the output which we are getting over here, we have to put it over here and we have to heat it, and then we'll get a pure mercury or pure copper. ठीक है, तो ये याद करना होगा थोड़ा समझ कर. Next is about अच्छा, Ria, tell me about the mercury one. Can you explain me? First we will combine with what, and then after that. Hmm. What, Shazan?
Metal.
No, wait. First Ria and then you.
Ma'am,
Ria, where were you?
uh, ma'am, is it like mercury plus oxygen makes
Hmm.
mercury oxide and
Hmm.
SO, like sulfur
Yes,
dioxide?
sulfur dioxide. And
And
after that, on further heating, what will happen?
and heating mercury oxide will make mercury metal and oxygen.
Hmm. Okay, good. Now, extraction of metals of the medium reactivity. Okay. Now, what is written over here? The metals in the middle of the activity series are iron, zinc, lead, and copper. So that's why I've asked you both to learn the reactivity series. So it will be very familiar with you. So in the middle of the activity series, you have these metals, iron, zinc, lead, and copper, are moderately reactive. Okay, not highly, not less, in the middle one. So these metals are usually present in sulfides or carbonates in nature. So what is the nature? Means what is the physical property of this metal? The physical property of the medium reactivity metals are that they are present as sulfides or carbonates in nature. So you can make a point and you can write nature, and then after that arrow, and sulfides or carbonates. It means the nature of these metals will be sulfides or carbonates. Now, these sulfides or carbonates are first converted into oxides. So what will happen? Sulfides and carbonates will convert into firstly with the oxide one. Why? Because it is easy to extract metal from its oxide. Now here, first of all, we'll go through this. See, here what was happening? Here first it changes into oxide. Here also what is happening? It will change into oxide. Why? Because to extract the metal from the oxide, it's very easier process. Okay? So you can make a point like this ki first of all middle reactivity, and then arrow, iron, zinc, lead, and copper, these are the middle metals. Now the physical nature of these metals are sulfides and carbonates, and after that on converted, firstly we will convert it into oxide, because to extract the metal from the oxide, this is a very easier process. Here also zinc is combining with the oxygen air, and after heating, what we are getting? We are getting the zinc oxide and sulfur oxide, same as this process, right? Here also the same process was going on, and here also firstly will convert into a zinc oxide, and after that what will happen? After that, calcination. So it's the process in which the carbonate ore is heated below its melting point in the absence of air. So there also heating process will be there now to get a pure mercury or copper metal. So in this also we'll heat it and we'll get a pure zinc. See, we are getting a pure Zn, which is a zinc. And same for aluminium we can do. And this is your iron. Okay? So
Okay,
you
ma'am.
can try to do.
Can you show the calcination process definition?
Okay, Ria, getting it? Means both will have the same process, only the metals are changing. And those were less reactive and these are moderately reactive. Okay? If you will get to know only one this equation, then you can solve like most of the equations with different metals, right? Because if you are familiar with the zinc, you can do iron, aluminium, magnesium. Okay?
Okay, ma'am.
Shazan done definition part. Okay. Next is what? Next is the extraction of metals of the highly reactivity. Now, in the highly reactivity, we know what are there? Sodium, magnesium, calcium, potassium. Okay? Now, what is electrolytic reduction in the highly reactivity? So, the salts of these metals, like chlorides, in the molten form are electrolyzed. So, the salts of these metals means, for example, sodium. Okay? So, so the salts of your sodium, like chlorides, means NaCl hota hai na? So, what will happen? In the molten form, these are electrolyzed. Now, the metal is deposited at the cathode, means the negative electron, and the chlorine is liberated at the anode, means the positive electrode. So here there's a two electrodes. Okay? This is a negative electrode, this is a positive electrode. Negative is known as the cathode and the positive is known as the anode. So this is a metal which is deposited, means your sodium, and here is your chlorine. CHLORINE. Okay? So the reaction will happen at the cathode, means where is your sodium, Na. तो यहाँ पे क्या होगा? Na plus and electron minus. Now you tell me why reduction is happening over here? Why not oxidation?
Because sodium is a
Hmm.
metal that gives electron. It
हाँ.
loses electrons.
It will give how many?
One.
Yeah, one. It's 281, right? Okay, so it will give one electron and it will reduce, means it will reduce one electron, correct? So that's why Na plus and electron minus, it will become Na, means 2 and 8, because it's important to complete the 8 in the outermost shell, so it will get reduced. And what about chlorine? Chlorine is how much atomic number?
Wait,
What is the atomic number of chlorine, Ria?
wait. Mom, it's
Ria.
17.
17, mom.
Hmm. 17, right? So what will happen? It will be 287. So it will be easier for chlorine to gain one electron or to lose seven electrons. What will
For
be the easier process? To gain, right? Huh.
yes.
So it will gain one electron and it will be
But over
oxidation.
there it is written plus 2E minus.
क्या हुआ?
But over there it's written it's plus 2e minus.
Because NaCl2 now, that's why it wrote like a 2 NaCl and it will get reduced to Cl2 plus 2 electron minus. You can also write only 1 electron minus because it is losing only one, I mean gaining only one electron.
Okay, I understood.
NaCl2 है ना process that, I mean the formula, that's why.
Right,
If you will
right.
write for only NaCl, then it will be only one. ठीक है? Now, so the high reactivity you got first is your Na, then it's your chlorine. So it's a metal which is a negative, which is there in the cathode, and chlorine which will be your positive. So here we already see कि Na क्या हो रहा है, reduce हो रहा है because one electron to complete its outermost shell, Na is reducing one electron, and to complete its outermost shell, chlorine is gaining one electron. Okay. So similarly, you can also do for aluminium. ठीक है, aluminium oxide, which is also called alumina, and with this your enrichment of ores topic is completed. Means in the okay, let me make it enrichment of ores. Enrichment, we talked about the three processes. First is your low reactivity, then your medium reactivity, and then your high reactivity. In the high reactivity we talk about NaCl2. In the medium one, your medium metals. What are medium metals?
Zinc, iron, tin, and lead.
And the low.
It's mercury, copper, silver,
Huh.
mercury, copper, silver, and gold.
Okay. So in the low, we talked about first about the mercury. So after heating, what is happening? Mercury is changing into a mercury oxide, and after that, on further heating, what is happening?
It becomes mercury metal.
Mercury metal. I'm writing. ठीक है? So, and what is enrichment of ores? Enrichment of ore means the removal of the impurities to make it enriched. That's why it's known as the enrichment of ores. And these all processes which we have learned right now, these are chemical or physical property.
Chemical.
Chemical properties, because here we are combining two and forming one or two output, right? So that's a chemical properties. And the physical property means it will depend upon the nature. And this is the different separation technique. So we'll learn three different separation technique: low reactivity, moderate, and high reactivity. And this is the nature of impurities. Okay? Okay. And this we already discussed. What is occurrence of metals? Acha, now you tell me what is ores. Hmm.
This one, concentration of
No,
ore.
no, no, not this one. Definition. What is ores?
Now, stone with metal in it. Metal
What?
inside.
Okay, Shazan, you tell me what is ores.
Um, ma'am, ores are substances, ma'am, which have elements like metal, like which have metals inside of them, metal and non-metal.
Metal inside a metal.
No, ma'am, like it contains metal and but it's just a big chunk of rock which contains some kind of metal or element. Um,
So, see, the ores is this now. Here, okay, let me read this one. The elements or compounds which occur naturally in the earth crust are known as minerals, and the minerals from which the metals can be extracted are called ores. Those minerals means the minerals from which the metals can be extracted. If we are like easily extracting the metals from the minerals profitably, so those are known as ores. ठीक है? It's not metal inside a metal. ठीक है?
Didn't say metal inside a metal.
अच्छा. This we discussed right now. There are three different techniques: metals with low reactivity, medium reactivity, and high reactivity. ठीक है. Now, tell me any example of a high reactivity.
Ma'am, reactivity example you want or the process?
Yeah. What?
Ma'am, you want the example or the process?
The process.
That's called electrolysis. Translate the answer. It's electrolysis of molten ore.
Hmm. Electrolysis are molting.
Electrolysis of molten ore, I said.
अच्छा अच्छा. Okay. So next is your refining of metal. What is refining?
Process by which the metal gets refined or more clean.
And
Hmm.
Gets
purified.
into purest state.
Hmm.
And the process by which metal is purified after reduction.
Okay. So refining means it is a process of purification of metals. Correct? When we further purify a metal after reduction, so that's a process which are called a refining of metals. So there are various methods of refining, but the most common method is your electrolytic refining. Okay? You have to study in this class only this process, electrolytic refining. This is the very important topic. So many metals like your copper, zinc, NiAg, Au are refined electrolytically. Now, what is the process? How we will refine the metals? What's the process of refining? So, in this process, a thick block of impure metal is used as anode. Now, see, this is the anode. Okay? This electrode is your anode electrode, which is a impure metals. And a thin strip of a pure metal is used as a cathode. So this is your cathode, which is a pure metal. Okay? Cathode is your pure metal, thin strip of a pure metal, and your anode is an impure metal. Now, a solution of metal salt to be refined is used as an electrolyte. The metal which we have to refine, which is used as an electrolyte. Like here, this is a copper. Okay? Cu2 plus, Cu2 plus. ठीक है, इसको क्या करना है? We have to refine it. Now, when electric current is passed, metal ions from the electrolyte are reduced as metals, which get deposited on the cathode. So, what is happening over here? When the electricity is passed, means the electric current is passed. So, what will happen? Hmm? From the electrolyte means these are your the electrolyte, the battery one. So what will happen? This will get reduced as a metal, which get deposited on which side? On the cathode side. Means what we are doing, we are making a impure metal a pure metal with the help of electric current, right? So an equivalent amount of pure metal from which anode get oxidized to metal ion and goes into electrolyte, and from there it goes to cathode and deposit. And why they are going to cathode? Hmm?
Because the electrons that gets attracted to the negative side. The plus
Ria, why?
electron plus positive electrons.
Okay. Ria, you?
Ma'am, I don't really
Hmm?
know. Ma'am, I don't know.
See. So we will go through with this diagram. ठीक है, तो ये एक diagram है. This is your cathode part. This is your anode part. Now there's a electric current which is getting passed through the cathode or anode, and this is your electrolytic refining solution where copper is there. And cathode is a thin strip of your pure metal, and anode is your impure metal. Now, if we are passing a electric current from the anode to cathode, so what is happening? They are getting deposited at the cathode side. ठीक है? Anode metal crack and deposit to the cathode metal. The metal will get cracked over here and it will get deposited on the cathode metal. Why? Because we are changing, we are refining it from the impure to a pure metal. ठीक है? See, anode, which is an impure, let's say copper rod. Cathode, which is a thin strip of copper, which is a pure. Now, electrolyte will be what? It will be CuSO4, means, acha, you will not, 1 second. Let me, you will, okay. So first we'll go through with this paragraph and after that diagram. So the cycle is repeated until whole the metal ion from impure block is dissolved and deposited on cathode. So क्या होगा? This cycle will be repeated कब तक? Until the whole your impure metal from the impure block is dissolved and deposit on which metal? Means on which electrode? Cathode electrode. So the soluble impurities go into the solution. Your soluble impurities, these are soluble impurities which are going to the solution, whereas the insoluble impurities settle down below the anode, and those are known as anode mud. So these are the anode mud, which are the impurities and which are settling down. Example, electrolytic refining of a copper. So here anode is a impure copper, है? Anode is a electrode which is impure, whereas the cathode is a pure copper. And the electrolytic refining is a solution of what? Copper sulfate, CuSO4. And on passing the electric current, pure copper is getting deposited on the cathode. Now we'll go again with this sentence. See, cycle will be repeat until your full impure block is dissolved or get deposited to the cathode electrode. Now the soluble impurities go into a solution. ठीक है? Soluble impurities क्या होगा? Like this copper. ये कहाँ है? It's there in the solution, right? This is your solution. ठीक है? So this is there in the solution, whereas the insoluble impurities will settle down below. This is your insoluble impurities. ये कहाँ पर settle है? In the below. Below what? Below anode. And these are known as the anode mud. And here anode, which is impure, which is whereas the cathode, which is your pure. So electrolytic refining solution which is CuSO4. So on passing the electric current, what will happen? Your pure copper will get deposited on the cathode side. It means basically this process is like we are changing the impure to a pure, from anode to a cathode, with the help of passing the electric current. That's it. ठीक है? समझ आया? Little.
Yes, ma'am.
I'm understood.
Okay. Corrosion we already discussed in class 9th, right? What is corrosion? Riya, Shazan.
Ma'am,
My page.
air and moisture reacts with metal and causes
What?
colors. Ma'am, air or oxygen and
1 second. 1 second. हाँ, go ahead.
Ma'am, when metal reacts with oxygen and moisture from the air, uh, uh, to cause change of color and eating away of the metal. It happens as rust in iron and
Hmm.
a black coat in copper,
Uh,
green coat in copper, and black coat in silver.
okay. Now, Shazan, you tell me what is corrosion?
Ma'am, she already told.
What?
Ma'am, she told right
Ah,
behind.
okay. She told, na. Now you tell.
It's a process by which the air and moisture it corrodes. It makes rust on the air. Like it have to be mentioned. It's a
So
process by
it's a slow process of eating of your metals, है ना? With the reaction of what? Reaction of your moisture, which is present in the environment. Example: rusting of iron, tarnishing of silver, which is green in color, means the copper one, which is a green in color. Formation of a green coating over copper, है ना? क्या हो जाता है? Green coating बन जाता है in the copper, and if we'll talk about the iron, there will be a brown coating. Correct? So
reddish
how
brown.
to prevent? Huh? What?
It was reddish brown. Nothing, ma'am, nothing.
Reddish? Means reddish brown or brown, dark brown. We can tell it like that. So prevention, how to prevent galvanization? Galvanization मतलब क्या होता है? What we will do, we'll coat a iron with a thin layer of zinc. Galvanization means we will coat the iron with the help of a thin layer of zinc. And it is done by dipping the object in a molten zinc. So what will happen now? We'll take a iron and we'll dip that iron in a zinc. May what we will do? We will dip it. So if we'll dip it, then the full coating will be there. The thin coating of zinc will be there. So it will prevent from corrosion of that metal. Alloying. What is alloying?
Mixing two types of metals,
Huh.
or
It's a
mixing a
process.
metal and a non-metal.
Yes, it's a process of improving the properties of metal by mixing the metal with another metal. If we'll mix the two of the metals, so then also we can prevent from corrosion. Last is your alloying of iron. Alloying of iron means the pure iron is very soft and stretches easily when hot. We can easily stretch it, correct? So it is mixed with a small amount of carbon and becomes hard. Why iron becomes hard? Because we'll mix a small amount of carbon, then it becomes hard and strong. Okay? So iron is mixed with many different types of metals to form different alloys. For example, iron is mixed with your nickel, chromium, steel. ठीक है क्यों? To obtain the hardness property of the iron. So what is the alloying of iron? Pure iron is very soft, and when we will add a small amount of carbon in it, it becomes very hard and strong. And iron is mixed with the many metals to form different alloys. For example, iron is mixed with nickel, with chromium, with steel, okay, which is very hard and which does not rust, because alloying is the process which prevent the iron from corrosion. Okay, okay. In the next, we will learn. Okay, so what is alloying of gold?
Adding
Alloying.
silver, copper, and gold.
What?
Adding silver or copper and gold to
Uh,
uh, not make it rust,
yes.
prevent
So
rust.
alloy of gold is made either with the silver or copper. For example, 22 karat gold means 22 parts pure gold mixed with the 2 parts of copper or Ag. Okay? So what we will do? We will made either with the silver or gold. Sorry, with the copper. Hmm. Painting is also a process of prevention. And we can paint. Okay? So it will help to, um, it will help means it will prevent the corrosion. Second is your greasing or oiling we can do. Third is your tin plating or chromium plating. Yes, Riya. Yes, yes.
Ma'am, once rusting happens, is there a way to remove it? Like if I
Uh, Means there's not a there's a very tough way to remove it. That's why if rusting happens, like you can also see in some of the old homes in the terrace, what will happen? Most of iron or steel is thrown, right? Why? Because in the rust, we can't use rust again. It's full damage. So to prevent it, we can do these processes: painting, greasing, uh, tin plating, chromium plating, galvanization. Okay.
yes, ma'am.
Okay. Now in the next class, we will talk about alloy. And after that, oh, after alloy means, only alloy topic is left, and this chapter will get over. And after that, what is there? ORG. ORG means carbon and its compound. This periodic classification is not there, no?
Um,
Lucky. Okay, so carbon and its compound. Okay. Only alloy part is left. But first, means tomorrow is Tuesday, no? Means on next Monday, first I'll check the notes of this chapter,
okay,
all
ma'am.
the points. Ria, not only one page notes. We have to make notes 2, 3, 4 pages. Okay? All
Ma'am,
the
what
points with equations. Okay? And I will also ask. And then after that, I'll start a lower topic because this is the last topic of this chapter. So it's very important for you to make notes point wise with full equations.
okay,
And
ma'am.
I will check. And you both will send me the PDF of your notes on next Monday
Okay, ma'am.
before starting the class.
Ma'am, can I send it in the group by Saturday or Sunday? Because I have.
No, 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 not in the group. Send me.
Ma'am, I'll
Okay?
send it to you on Saturday or Sunday because
Huh.
I'm a little busy till Saturday. There's school work, lots of.
Means you will send me on the Sunday.
Yes, ma'am.
Okay. Till Monday you have time. You can send me anytime. Shazan, you also. When will you send?
Ma'am, I will send on
On?
before Monday. I will send.
Before Monday. At least total 4 topics are there. Na? At least
Ma'am,
10
all
page
the four
notes.
topics will be there, and all of the
All the
points
four
will be there.
topics.
Yes,
All
ma'am.
the four topics.
All points will be there.
All
Nothing.
points. If one topic is there and if the question is also related to that topic, so also you have to write the equation. Sick.
Okay, ma'am.
Ma'am, one question.
What question?
Ma'am, can coins rust?
Coin also rust. Yes.
Does
No.
I said it does rust. It happens. It has
Ha.
been.
Ma'am, old
Hmm.
coins that they like that people have found they're rusted.
Where?
So,
What?
like, ma'am, like nowadays coins, not the older coins. The coins,
The older coins are rusted.
the coins you have now, can they rust? Because they're like alloys of few metals.
Means nowadays what is happening now? People are to prevent them from corrosion, they are applying lots of process in your coin. But before there's were maybe not that much of knowledge, or you can say the process. That's why the older coins rust, and now the coins are not rusting.
Okay. Um, thank you,
Mm-hmm.
ma'am.
Huh? Okay. Okay, okay. I thought you were asking some questions. Thank you, ma'am. Bye, ma'am.
One
Okay,
question.
take care. But don't forget to make notes.
Okay, ma'am.
Okay, bye bye. Thank you.